Step into a room that is almost dark. On a bench, a tiny sensor waits silent, patient. Then it happens. A single tick. One photon arrived, met silicon, and left a trace. That soft click is more than sound. It is the moment a possibility became part of the world's ledger. Far away, in the long tunnels of LIGO, lasers paced between mirrors polished to a perfection that eye can't judge. A passing ripple in space-time, born from colliding black holes half a universe away. Nudges one mirror by less than the width of a proton. The instruments answer with a tremor of light on a screen. Again, the record grows. The cosmos has whispered, and we've written it down. Tonight's story begins with those records, because in the quantum world, before a trace is made, an electron is not here or there, but poised between outcomes, a mist of possibilities. And yet the instant a detector clicks, the haze clears. The experiment has chosen. What changed? What turns maybes into one durable fact? We often say observer and pictures of watchful eyes follow, but physics is quieter and more honest. An observer need not be a person at all. A grain of photographic film, a crystal in a Geiger tube, a droplet in a cloud chamber. Any of these can notice. To observe is to leave evidence, to catch, to copy, to amplify a microscopic event until it becomes a mark that will not easily fade. The world observes itself all the time. We are its most curious witnesses, not its magical makers. Hold a single photon camera to the dark and wait. Each click is a commitment. Energy arrived here, now, not there, not later. Open the logbook and you'll see a constellation of such commitments. Tiny stars of ink that, together, sketch a picture of reality as shared experience. Between the clicks lies possibility. Across the clicks, history. But the clicks raise hard questions. Where, exactly, does observation happen? At the sensor's surface? In its amplifier? On the hard drive where numbers cool into permanence? Can a system be both undecided inside a box and decided from the corridor outside? And why does watching gently, again and again, sometimes hold a quantum system in place, as if attention itself could shelter a delicate flame? In the minutes ahead, we'll replace myths with mechanisms. We'll see how information becomes fact, how the environment itself, air, light, walls, broadcasts what happened, and why the universe's bookkeeping leans toward the irreversible. We'll meet thought experiments that unsettle and real experiments that guide. No equations tonight, only careful language, faithful images, and the humbling realization that to measure is not merely to peek through a window, but to help write a page of the world. If a single click can change the story the universe tells, then the question is unavoidable. What truly counts as looking, and how does looking shape? What is there to see? Dim the lights. Imagine a silent lab at midnight. On a sensor the size of a fingernail, one lonely pixel flickers to life. No one is watching, no fanfare, no gasp. And yet something has happened that wasn't true a moment before. A single photon arrived, left its tiny signature, and turned possibility into a fact. An observer in physics is not a pair of eyes, but anything that leaves a mark, crystal grain that darkens, a counter that clicks, a byte that flips from 0 to 1 and stays that way. Observation is the art of making a record, a trace that endures long enough for the world to point at it later and say, that. How does a ghost of a signal become a headline the universe can't ignore? The journey begins with a whisper. First, transduction. A photon jostles an electron. A passing particle leaves a whiff of ionized air. A faint magnetic tickle nudges a loop of wire. Then amplification. The timid nudge becomes a cascade. More electrons knocked loose, a chain reaction tumbling forward like a line of dominoes. Next comes latching. Some simple, sturdy mechanism decides, yes, this happened, then flips into a new state that won't easily flop back. Finally, recording. The result is copied into places that last. Silver grains in film, a glow on a phosphor screen, a time-stamped entry on a hard drive. From whisper to headline, from maybe to now we know. But there's a price for knowing. To take a pulse, you have to touch the wrist. In the quantum world, every question is also a nudge, however gentle. This isn't clumsiness, it's connection. You can't learn the temperature of a glass of water without your thermometer sipping a breath of its heat. You can't ping a distant airplane with radar without your pulse giving it the faintest tap. Information is a handshake, and even the softest handshake leaves a fingerprint. So we learn to choose how we ask. Sometimes we need a sharp answer, use a strong measurement, decisive, all in. The system is driven to announce a definite outcome, and the ambiguity is pared away like a sculptor's final strike. The cost? We've changed the thing we measured. We won't get the old superposition back. Other times, we prefer a quiet hint. We use a weak measurement, so gentle, it barely nudges the system. One hint is noisy, nearly useless on its own. A whole chorus of hints averaged together paints a trustworthy picture while disturbing far less. A camera flash freezes a hummingbird's wings in mid-beat. A long exposure catches their blur without blinding the bird. Two ways to ask, two kinds of answer. If the act of measuring is a one-way street, why does it feel so irreversible? Because once a signal is amplified, it spreads. A single spark maps itself into a million electrons, into a glowing pixel, into a saved file, into a screenshot in a message thread. Those are copies, and many copies are hard to unwind. Try to unlight a whole city one bulb at a time, and you'll feel the arrow of time tug at your sleeve. Information, once widely shared, behaves like spilled ink. Theoretically recoverable, practically not. That practical irreversibility is why a shaky whisper becomes a stubborn fact. It's also why we need to retire a few myths. Myth 1. Observation needs a mind, doesn't. A fog droplet that condenses around an ion track has observed a passing particle by writing a visible streak in midair. A camera chip that changes a pixel has observed a photon. Consciousness may marvel at the result, but the world does the writing. Myth 2. Observation means seeing. It doesn't. If a particle bumps into a wall and leaves a trace of energy behind, if light scatters off a dust grain and carries away the story of its position, that information has been laid bare. Whether anyone checks the ledger is irrelevant. The environment is a relentless witness. Myth 3. Observation is optional. In practice, it's everywhere. Air, light, walls, and warmth are busybodies. They gossip about systems all day long. Keep something isolated enough, and quantum strangeness blossoms. Let the world listen in, and those blossoms fold back into buds we call classical. Let's step into 3 rooms where we catch the quantum in the act. In the first, a cloud chamber rests under a cold lamp. A seed of alcohol vapor hangs just at the edge of condensation. A cosmic ray knifes through, leaving a trail of ions that coax droplets from the air. A faint silver line blooms and drifts, matter's most delicate autograph. No eyes required. The track is the memory. In the second, a single photon imager waits in darkness. The detector is wired to notice the tiniest electrical avalanche. One photon arrives, a controlled cascade follows. Lone pixel lights. Another arrives. Another pixel. Over minutes, a pattern emerges, one dot at a time. Each unassailable, you can save the file, transfer it, print it on paper. You have turned quanta into culture. In the third, the tip of a scanning tunneling microscope hovers a few atoms above a metal surface. A trickle of electrons tunnels across the gap, exquisitely sensitive to distance. By sampling gently, line by line, the instrument coaxes a map from the substrate, hills and valleys of electron density. Atoms like rounded stones in a stream bed. No big hammer blows, just a million careful whispers, aggregated into a portrait. Different devices, same story. Transduce, amplify, latch, record. And so we come to a deeper, subtler question. Where in that chain does observation happen? Is it when the photon first grazes the sensor? When the amplifier unleashes its cascade? When the bit flips on the drive? When a human reads the number? There is no single sacred line. The world doesn't stamp a moment observed in red ink. Instead, there is a process that grows from private to public. Early on, information is local and fragile. Clever experimentalists might, in principle, erase it. As it spreads into many electrons, into many atoms, into many machines, it becomes robust. At some point, the outcome is in the world enough that undoing it would be like trying to recall 1,000 whispered secrets already told. That's when we call it a fact. If that sounds less like magic and more like bookkeeping, that's the point. The observer effect is not a ghost in the lab. It's the accounting of information. Who has it, who could have it, how widely it's been copied, at what cost it might be erased. A measurement is a tiny story becoming communal memory. And yet, even with all this clarity, a question waits in the hallway outside a certain sealed box. If an observer is any device that records, what happens when the device, the record, and even the air that carries the gossip are all locked away from us? Imagine a box on a table. Inside, a quantum trigger, a detector, a tiny mechanical hand, an entire measurement chain ready to make a fact. Also inside, something warm-blooded, whiskered, and asleep. From the outside, the world stands still. No light leaks, no whispers escape. Somewhere in there, did a fact already happen? Or does it become a fact only when we open the lid and let the story spill out? And what if, instead of a cat, it's a colleague, a friend, running a quiet experiment in a soundproof room? To them, the detector clicked an hour ago. To you, the lab is still in limbo. This fact is real. In the chapters ahead, we'll meet these paradoxes with open hands and steady eyes. We'll see how thought experiments sharpen our language, how the environment's constant attention hides quantum strangeness in daylight, and how different philosophies of physics try to reconcile private whispers with public truth. For now, remember the Midnight Pixel didn't need an audience. It needed a place to write its story. That, in the end, is what counts as looking.